Hello. So this one is called a learning check, capital L, capital C, and that's what you're going to see in the assignments when you're working through all of these. They are always going to be a video, but sometimes it'll be a video quiz. Sometimes it'll be take notes. Sometimes it'll be create a problem of your own and submit that to the assignment. So just watch and see which one it is. If it is a quiz one, the quiz questions will just pop up as you go along. Just make sure when you get all the way to the end, if you were happy with your quiz, that you hit that submit button. Otherwise, it won't record to Canvas. And if it is a quiz one and you get to the end and you're like, I did not like this attempt, then just restart the attempt. Don't submit your score to Canvas until you're happy with it. These learning checks are here to see if you are on the way to understanding the topic. So watch them as many times as necessary. You can even watch them again before you take the final, just to make sure, okay, yes, I do remember how to do all of this. So if you are comfortable with how to do how many nanoliters in 2.0 capital M capital L, you can pause right now, do your work, and then unpause to check your answers. If you're like, I'm not really sure what to do with from that point, then you keep listening until you get to the point where you're able to pause and work on it. So how many nanoliters? How many nanoliters? That is the question. Are in 2.0 capital M capital L. That is the number. Okay. So step one, whenever we're doing these things, known equals question mark unknown. And that is just reorganizing the word problem to make it simpler for you to look at. The known is the number. 2.0 megaliters is equal to how many nanoliters? Nano is abbreviated with lowercase n, and liters is a unit for volume, so I'm going to use a capital L for that. These guys have the same roots, so I know that I can do a conversion from megaliters to nanoliters. So did you notice I said mega, capital M, not milli, not micro. So read super carefully on that. So now, if that was your stopping point, you didn't know what the capital M meant, but now you're like, oh, I think I know what to do now. Now pause the video and keep going. If you're like, nope, I still don't quite have it. Next thing is to find our path. We're going from mega to nano. Okay, so we are going to be going down the staircase because we're going from mega to nano. That's why it's important to rewrite that in step one. So if you didn't know that, that is the reason why the known goes on the left and the unknown goes on the right, because we're always going to where we want to find something. And it's going to help us make sure we have the path correct. If the path is going from above to down, we're going to be going to the right. So we're going to move the decimal to the right. How many times to the right? Let's count. This is one step, but this guy's a weird one. This is a big step. So this guy counts as 3 steps. Whereas between kilo and hecto is only 1 step. So at this point, we have to go 4 steps, 5 steps, 6 steps, 7 steps, 8 steps, 9 steps. Ooh, there's a big one. 10, 11, and 12 steps. Another big one. 13, 14, 15 steps. And where we're going, we went from mega to nano. So we're going to the right. So our decimal place has to go to the right. 2.0 is where we're at right now, but we have to move that decimal place, what, 15 times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our new decimal place is going to be there. So we're going to fill in zeros. So we had 1 0 already, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you were doing this before you learned about scientific notation, you would go back in and do all of your commas every 3, remember? From math class. And you have this big, humongous number now. Hey, are we going to want to keep it like that? No, we're not going to want to keep it like that. 2.0 times 10 to the 15. Because I'm going to be moving that back 15 times until I get back to I only have one value over here. You only want to have one non-zero to the left of the decimal. So then my answer is 2.0 times 10 to the 15 nanoliters. I'm always going to include my units there. And if you're familiar with sig figs, the reason why I left the 0.0 is because I started with the 0.0, but we're going to do a lot more on sig figs if you haven't gotten to that yet. So if you got stuck on any part of this, go back, restart the video, try it from scratch again, and then go, okay, yeah, I'm comfortable with this. And then we usually have a couple problems. So today we're only going to have 2 problems. If you're comfortable, hit pause and solve how many meters in 0.05 centimeters. Do always keep your work for these because you never know when you're going to need it as a reference. If you're like, nope, I'm still not quite there. How many meters? That's the question. So it goes on the question side. How many meters on the right side? Okay, and the number is 0.05 cm is our known. It's the one with the number, known number. Okay. And so when we find this on here, I'm going from centi to meter. There's no meter listed, but remember, it's a base unit. Okay. And so meter is a unit of length. So we're going to go here. Okay, now if that is enough for you to figure out the path and the answer, go for it. Hit pause now and then keep going. If you're still confused on which way we're going, this time centi to meters, which direction are we going to go? We got to go up 2 steps to get that way. So we're going up and to the left. So we're going to move the decimal place to the left this time. 0.05 to the left, 1, 2 places. So there's my new decimal. I fill in my new 0. Okay, so that's 0.0005, or to make it more acceptable to write in math, 0.0005, so that you have those placeholders there. So my 5 is in the tens, hundreds, thousands, in the 10,000 spot. And this is now in meters, so make sure you're always adding your units. And I'm going to box that answer for my work. And again, keep as much reference as you can, sample problems in your notes so that on the quizzes and tests, you can find a similar sample problem and then go, okay, this one's close to that. It just, instead of using meters and centimeters, maybe it did micro to hecto. But notice if I'm going from micro to hecto, I'm still going to go to the left. I'm just going to have a different number of zeros to move around. So in chemistry, we're going to learn more about using what computer science people call algorithms. You're going to learn about the process being important and being able to use that process regardless of the starting numbers or the path numbers. And once you get in the habit of using this more like an algorithm, then chemistry class will get easier. So you guys are doing great. Again, if it was a video quiz one, wait all the way to the end so you can submit those answers, or restart at this point and try these on your own. And have a great day.